This is me, standing next to the largest bird alive today, the ostrich. Comparing it to the colossal elephant bird makes it look small, but the elephant bird wasn't the tallest, with that title going to the moa. But Pelagornis, the bird with the longest wingspan, was arguably the true king of birds. But what made these birds so enormous, and why are they no longer around? Our story begins with the first written records of elephant birds in the 1640s, when the governor of the French East India Company described a large ostrich-like bird said to live on in the remote regions of Madagascar. But it wasn't until the early 1800s that European explorers finally uncovered their remains. Giant eggs and bones. By 1851, scientists pieced these bones together, reconstructing this massive animal and naming it the elephant bird. Yet, by then it was nowhere to be found. It was extinct. However, in the 1930s, something strange was found on Australia's western coast, an elephant bird egg. But how did an egg from Madagascar end up over 6,000 kilometers away? It's thought that these eggs drifted across the ocean until they settled on the shores of Australia. Okay, let's answer the question I'm sure you have in the back of your mind. How big could they grow? The tallest individual stood at an incredible 3 meters. That's almost twice the height of the average person, and that's just their height. When it came to weight, they could reach an impressive 700 kilograms. But why did they evolve such a huge size? Like emus, kiwis, and ostriches, elephant birds belong to a lineage of flightless birds known as ratites. But Madagascar has been an island since before this lineage arose. So how exactly did these flightless birds get to Madagascar? Well, the ancestor of all of these birds is thought to have been able to fly, managed to spread out across the world before it came extinct. And in their isolation, the ratites' large sizes and flightlessness independently evolved in each of their ecosystems. It may be hard to believe, but DNA has revealed that their closest living relative is the kiwi, which, as you know, is found all the way over in New Zealand. Elephant birds and kiwis are by no means close relatives, with their lineages splitting from each other some 54 million years ago. This DNA evidence is further supported by the discovery of a tiny flying kiwi relative known as Prehistoric from 16 million years ago, making it likely that it reached New Zealand from Australia around this time, before losing its wings and evolving into modern kiwis. It's likely that a similar flying ancestor made its way from Australia to Madagascar before evolving into the elephant bird, although we will never know for certain, as Madagascar's fossil record is notoriously empty, meaning the key to understanding their evolution lies in the form of DNA preserved in their eggshells. This DNA evidence has revealed that the two genuses of elephant birds are not at all genetically close to each other, having split around 27 million years ago. This genetic divergence is so significant that it may warrant placing them in different families. The reason they'd become so big is due to a phenomenon known as island gigantism. Due to the lack of predators, they are free to grow as big as they can, taking the role of large herbivorous mammals on other continents. Like their closest relative the kiwis, elephant birds had reduced optic lobes, a trait commonplace among nocturnal bird species, suggesting that they too were nocturnal. Due to the lack of a fossil record, we can only speculate about possible forest-dwelling species, although the species we know were grazers and browsers, similar to South America's rhea. Elephant birds were common across the island, but they became extinct around 1,000 years ago, which brings up the question of what could have caused a bird that lived for tens of millions of years to go extinct. Their disappearance coincided with the arrival of cattle from Africa, which resulted in the mass burning of Madagascar's untouched landscapes. The burning of their habitats, combined with people hunting them and eating their eggs, resulted in the elephant birds becoming extinct within a relatively short time, marking the end of a lineage that existed for 54 million years. It's 1838, and a trader living on the eastern coast of New Zealand's North Island reports that he had been shown several huge fossils that he was certain were the remnants of an emu, noting that the natives add that in times long past they received the traditions that very big birds had existed, but the scarcity of animal food, as well as the easy method of entrapping them, had caused their extermination. This same trader was further told that these emu-like birds still lived on in remote corners of the South Island. This mysterious bird was known to the indigenous people as the moa. The moa remained completely unknown to Western science until a bone was sent to paleontologist Richard Owen. Despite his extensive knowledge of fossils, these bones left him puzzled for years, until he concluded that the bone belonged to a large extinct bird similar to an ostrich. Many people were skeptical of his theories, but when more and more of these fossils were found and placed together, they came to form the skeleton of a giant bird. Since then, moa remains have been found all over New Zealand. Even its feathers have been found, revealing that they were mostly brown, with a few having a speckled pattern. Moas rivaled elephant birds in size, although historic estimates were not really accurate, as their skeletons were reconstructed in a fully upright position, even though they had probably held their heads forward similar to a kiwi. With their longer necks, they would have been able to both graze and browse taller vegetation. The tallest of the moa reached 3.6 meters in height, much taller than the elephant birds, yet at 230 kilos, they are much lighter. One other interesting question of the moa is what it sounded like. It had similar vocal features to swans and cranes, known for their deep calls that travel long distances, which tells us that moas also likely communicated in this way. Like the elephant bird, moas were also ratites, with their closest living relative being the tinamou, a South American bird which is still able to fly, albeit not very far. So far, 11 species of moa have been identified, although in the past it was believed that far more species existed, due to their great variation in size. This is caused by the animals changing in size rapidly during glacial periods, following the trend of animals becoming larger in colder environments. The earliest moa remains found so far date to about 19 million years ago, where two already gigantic species existed, but it's believed that they actually arrived in New Zealand much earlier, around 60 million years ago, and that the modern species all share a common ancestor just 5.8 million years ago, although there were likely many more species before this that never cemented themselves into the fossil record. A long time ago, when sea levels were much higher than they are today, much of New Zealand was submerged underwater, and evidence had implied that the moas on the remnants of the North Island eventually died out. But when the two landmasses eventually reconnected, moas recolonized the North Island. The two islands shared some moa species, such as the broad-billed moa and the bush moa, yet most were restricted to just one of the two islands. Moa had a varied diet, consisting of many different species of plant, with each species adapted to a specific environment, but they all occupied a similar ecological niche to large browsing mammals and other landmasses, and some plant species even evolved defenses against the moa. It is believed that they were a K-selected species, meaning a species that is close to carrying capacity, and so evolved certain traits such as having fewer offspring, but investing more time into them, much like many other species of birds endemic to New Zealand, like kiwis. From hatching, moa may have taken a decade to reach full size. Their eggs were remarkably delicate, at just 1 millimeter thick, astonishingly thin for an egg so big, which meant that the much smaller and lighter males had to incubate them. Unlike elephant birds, moas had a natural predator, the colossal horsed eagle, a bird that once ruled over New Zealand, yet became extinct after the moa disappeared, due to New Zealand being isolated for 80 million years. Its ecosystems were extremely vulnerable. The first Polynesians arrived in New Zealand by 1300, and within 145 years, every single species of moa had disappeared. Like the elephant bird, their extinction was driven by hunting and the burning of their forests. But in the case of the moa, introduced predators also brought about their extinction. The rediscovery of the takahe, which had previously been only known from fossils, proved that some birds can remain undiscovered for many years, but the moa's large size makes it unlikely that it could have been hiding out there undetected. Now that we've covered the biggest and tallest birds, it's time to take a look at the bird with the largest wings ever. Although not recent at all, last living 2.5 million years ago, it's still a fascinating example of evolution, especially as it had wings so huge you wouldn't even believe it. The currently living bird with the longest wingspan is the wandering albatross at 3.5 meters, less than half of Pelagornis' 7.4 meters. Pelagornis' fossils have been found across the world, indicative of a migratory species that covered vast distances, and due to its short legs, it's believed that it stayed near cliffs, where it would have been able to start flying from. The reason for these huge wings is because it gave these birds significant gliding power, which allowed them to travel and hunt over vast distances. This bird's disappearance is a mystery, as no one has really given any hypothesis for its disappearance. But if I had to throw one out there, it would be that the decreasing sea levels pushed its nesting sites inland. Evolution of birds is interesting, but what about the evolution of the largest land animals? Elephants. Click here to find out more.